Welcome back to part 2 of section 3.4. We're going to continue talking about solving these logarithmic and exponential equations, and we're going to see a few more challenging problems as we go through. So for number 14, isolate the log. So you want to start by dividing both sides by 2. So we get the log base 5 of 3x equals 2. Now we want to undo the log. To do that, we're going to use exponential with our base of the exponential being the base of the log, which is 5. So log base 5 raised to the log base 5 of 3x equals 5 squared. So we can do the 5 and the log base 5 cancel out, so 3 to the x equals. Now 5 squared is 25. So to isolate the x, just divide both sides by 3. X equals 25 thirds. Now we can leave it like that. If you really want to change it to a decimal, 8.333, but remember it's rounded. When I check, because I have the exact that's easy to work with, 2 log base 5 of 3 times 25 thirds equals 4. So it's 2 log base 5 of 25 equals 4. So if you type that in, you're going to get 4 equals 4. It's a nice solution. And there we go. Looking at problem number 15, this is where they start to increase in difficulty. I can't isolate one of my logs. That 1/2 there at the end is really going to mess me up. So what I have to do is I have to use my properties of logs. I'm going to condense this left-hand side. So because it's subtraction, it's the quotient property. So we have 1 log base 4, x over the quantity of x minus 1 equals 1/2. Now to undo the log of 4, log base 4, we're going to use exponential. 4 is the base. So 4 to the log base 4 of x to the x minus 1 equals 4 to the 1/2. The 4 and the log base 4 cancel, so it's x over x minus 1 equals, and 4 to the 1/2 power is 2, because it's the square root. Square root of 4 is 2. Now, a little tricky to solve this. So what we can do is we can put it over 1, and now it's in a more familiar form. Now we see that proportion. So to solve, we cross multiply. X equals 2 times the quantity of x minus 1. So x equals 2x minus 2. Subtract 2x from both sides. Negative x equals negative 2. Divide both sides by negative 1. X equals 2. So we could do the log base 4 of 2 minus the log base 4 of 2 minus 1. Log base 4 of 2 is actually equal to 1/2 minus the log base 4 of 1. So it's 1/2 minus 0 equals 1/2. 1/2 equals 1/2. So we found a nice, good solution. Next page, please. Number 16, once again, those more complicated problems. Log of 5x plus the log of x minus 1 equals 2. Because we have log and we can't isolate just one, we have to condense. Here, it's addition, so we're going to use that product property. So the log 5x times x minus 1 equals 2. Remember, log is log base 10. So to undo that log base 10, we're going to use exponential where 10 is the base. The log base 10 and the 10 cancel out, so we have 5x times x minus 1 equals, and 10 squared is 100. What I can do is I can divide both sides by 5, and that gives me x times x minus 1 equals 20. Now I need to solve, so I need to distribute the x. X squared minus x equals 20. It's a quadratic, get it equal to 0. X squared minus x minus 20 equals 0. And this is factorable. X and x, now to multiply to negative 20 and add to negative 1, it's going to be a negative 5 and a positive 4 equals 0. So we have x minus 5 and x plus 4. So our solution's x equals 5 and x equals negative 4. It's very important that you check these. So for our check, log of 5 times 5 plus the log of 5 minus 1 equals 2. So you get the log of 25 plus the log of 4 equals 2. When you type those into your calculator, you get 2 equals 2. So the 5 is good. Now for the negative 4 log, 5 times negative 4 plus the log of negative 4 minus 1 equals 2. We get the log of negative 20. And as soon as I see the log of a negative number, I can't take the log of a negative number. I'm not even going to look at the rest of it. As soon as I see that it doesn't exist, that negative 4 is extraneous. It didn't work. Our only solution is x equals 5. Next one, very similar. Condense. So we get the log of x times x minus 9 equals 1. So now, remember, this is log base 10. So to undo the exponential, we're going to use 10 as our base of the exponential. So 10 to the log base 10 of x times x minus 9. The log and the exponential cancel out. So it's x times x minus 9 equals 10. X squared minus 9x equals 10. It's a quadratic, get it equal to 0. Subtract 10 from both sides, so x squared minus 9x minus 10 equals 0. And we can factor. X and x. Multiply to negative 10, add to negative 9. It's going to be a negative 10 and a positive 1. So our solutions, x equals 10 and x equals negative 1. Make sure to check both. Don't always just throw out the negative. There are cases where the negative does work. So the log of 10 plus the log of 10 minus 9 equals 1. So it's the log of 10 plus the log of 1 equals 1. And actually what it is, it's 1 plus 0 equals 1. So 1 equals 1. It's a nice, valid solution. Now with the negative, log of negative 1. Once again, as soon as I see that, I'm not even going to continue with the rest, even though I am right now. But you can see as soon as you get the log of the negative, throw it away. Can't take the log of a negative number. X equals 10 is our only valid solution. And one last question. You have deposited $500 into an account that pays 6.75% interest, compounded continuously. There's our magic words. We know it's going to be P equals E to the RT. That's the continuously compounding. How long will it take for our money to double? So we want to know what T equals. That's our time. Now, our initial investment, A equals P times E to the RT. So A is our amount in the account. P is our principal, the initial amount. That's 500. The rate, 6.75%, is 0.0675. Now we want to double our money. If we're doubling our initial investment, that's going to be $1,000. 1,000 equals 500 times e to the 0.0675 t. Isolate the e. Divide both sides by 500. 2 equals e to the 0.675 t. To undo the e, we're going to take the natural log of both sides. The natural log of 2 equals the natural log of e to the point 0.675t. The natural log of 2 equals, the natural log and the e cancel, 0.0675t, and then divide both sides by 0.0675. So in the end, we get t equals. And when you do your division, you're going to get about 10.269. So it's going to take about 10.25 years, about 10 and a quarter years to double our money. And that's just using our methods of solving an exponential equation. Okay, thank you, and I will see you in the next video.